Hi, this is Sambasam, Assistant Professor, SNS College of Technology. In the previous two videos, we have discussed about an uh, projection of solids, especially for a pentagonal prism, which is perpendicular to an axis. And the next video, we have discussed about hexagonal prism parallel to an axis. Now we are moving towards another sector of an hexagonal prism, which is projected based on the one of its side is perpendicular to an axis. So, as I said earlier, the perpendicular line has to be drawn in a vertically 90-degree perpendicular to an xy axis. If it is in parallel, we have to draw a parallel line equal within equal inclined surfaces with the distance of some which is are represented in questions. But now we are not moving about the questions; we are moving about the projection of an solids based on our construction right now. So the first and foremost is we have to draw the line which is represents like in the axis, as I said earlier, right? This is an axis we are going to represent. So by naming itself, as I said earlier, this will be an x and this will be an y. Similarly, this will be an horizontal vertical plane, and this will be your horizontal plane, right? So now, as I said earlier, right? So we can think this is as a side of 25 mm. So I like to draw from this position. This is from the side of make this as side as 25 mm as I mentioned here, right? Then I have to paste like this. So similarly, from this point, this will be as 90-degree and this will be uh, is 25 mm with an angle of minus 30-degree. So it will be represented like this. So again, I have to make this as 25 mm and I have to draw the position which is represents the straight line. Similarly, for 25 mm, and again, I have to draw from this position because this is a easier way where compared to that. The size of 25 mm and angle is 30. So similarly, we have to draw this. So I like these things to be in different colors. So I totally select this till this point. The color will be changed, and so I am going to with the red color. So it represents the red color right arm. So before entering that, we have to name his. This one is A, and we cannot see the back side, so will be represented as 1. This will be B, the back side is represented as 2, and this will be C, and the back side is represented as 3. This will be D, the back side is represented as 4. This will be E, back side is represented as 5, and this will be CF represented as 6. So the front portion and every portions we can able to see will be represented in a different way. So this is how it has to be represented. For this understanding the clear dimensions, we can able to draw this from this is 25 mm. Similarly, I have to identify the angle between. So this and this is the angle of distance of 120. This is the regular pentagonal prism. So now I like to draw the line which is the reference from this point to see the top view. So I am going to take this as a reference line and I am drawn here. Similarly, from this point, the reference line always moves towards the F. So I have to paste this. Similarly, the line has to be drawn from here. So the reference has been drawn. Then the height of the pentagon, we will assume that this will be as 50 mm, right? So I have drawn the 50 mm line vertically upwards. So when I compare, when I have to draw the reference lines, right? So this the lines will be joined like this, and similarly the line will be joined, and from this point the line will be joined with it to each other. So the end. So I like to change this color. So I am selecting every part of the diagram I have drawn, and going for the color change with an red color. So this is how represented right now. So to identify the total height, this if you use smart dimension, when we click this, it automatically represents how much it has been developed. So similarly, we have to mark the points right. So from this view, we can able to see B, and it has to be represented as dash, and we cannot able to see this part. So we can represent as A dash. Similarly, this part we can able to see C, and we cannot able to see the F dash. So similarly, this is D dash. We cannot able to see the E dash. So I tracked about for the clear visibility. Similarly, this one also I am tracking above for the clear visibility. So similarly, in the opposite direction, we will be marked as this will be the two dash visibility seen and one dash we cannot able to see. So I have marked it like this. Similarly, the 3 dash has been seen and 6 dash we cannot able to see. Similarly, this part 4 dash we can able to see and 5 dash we cannot able to see. So similarly, I like to move this one in upper one. This is how the dimension has to be drawn right now. So when you see that how the difference has been made by using an normal using a scale, but instead of while we are using in solid edge 19 software for fluid diagram, this shows the representation how the diagram has to be drawn in a graphical way. This will able to understand clearly for the students where you can where a basic skills to understand how the concept has been working, how the diagram has to be drawn from using this point of view. So similarly, when you take the dimensions from each part, we can able to understand that whether the axis and differences has been hyped or not. So every axis is we can able to see that every axis we can make it as so 120 degrees. So we can able to see similarly. I have to click here and this one we can able to see everywhere you can get an 120 degree. Similarly, the total length of this will can be applied by using a smart dimension. So when you click this upper part, this will be 21.65. This will be 21.65. So the difference between two sides is equally distributed because this is how the pentacle diagram has to be drawn here. Hope everybody understood how the basic diagram of the solid projection has been clearly explained. I will catch in the next video. Till that, bye bye. This is Sam signing off by Samson, Assistant Professor, SNS College of Technology. Thank you all.